So our last method of solving systems of equations is to solve by elimination, and this is probably the method, if you go any further in math, that you would end up using the most. It shows up again in linear algebra, starts Gaussian elimination, things like that. So here, when we're solving by elimination, what we're going to do is we're going to basically add the two equations together. We're going to add some multiples of the equations together so that one of the variables is eliminated, okay? So, because remember, we can do that. We can, if we have two things that are equal to each other, and then we have another set of things that are equal to each other, you know, we have one equation that's true, a second equation that's true. If we add the two equations together, left-hand sides added together, right-hand sides added together, that resulting equation is still a true equation, right? So in this case, so first step is I like to add, so I like to have my whatever variable I'm going to try to eliminate, I like to have that be opposite signs. So you can choose to eliminate x or you can choose to eliminate y. Obviously, just adding the two equations here is not going to eliminate either of the variables, so we are going to have to multiply. Easiest thing to do is to multiply the second equation by 5. So our resulting system, because remember, so long as you do the same thing to both sides of the equation, you have not made any any change to the equation. So we've got 5 times 2x will be 10x minus 5y equals minus 15. And now we can add the two equations. Okay, so we multiplied one of our equations by a non-zero constant, never multiply by 0, and that allowed us to be able to add our equations and eliminate the y's because they will cancel when we add the equations. All right, so we're going to have 10x plus 3x is going to be 13x. The y's are going to cancel, and I've got 2 minus 15, so that'll be negative 13. And then obviously we're going to divide by 13 on both sides. We're going to get x equals negative 1. So that's good. We're halfway there. We are going to solve the resulting equation for the remaining variable. We did that. What we need to do now is to substitute into the original equation, either one of them, to solve for our second variable. So usually here you're going to pick whichever one looks easier to solve for. And so I'm going to substitute into the second equation. So we had 2x, so 2 times negative 1 minus y equals negative 3. So we've got negative 2 minus y equals negative 3. That's going to be negative y equals negative 1, y equals 1. So there's our solution, x equals negative 1, y equals 1, otherwise known as the point negative 1, 1. And of course we can check that by graphing, but I'm not going to this time. Okay, so some more practice with elimination. Here we probably we need to do some rearranging, right? Because we've got y's on both sides of the equal sign, one on the left side, one on the right side in the second equation. So we do want to rewrite our equation. So we've got, let's see if I can go back. So we've got x minus 2y equals 7 and x minus y equals 4, right? And now here, what's going to be easiest to eliminate is going to be the x's, because I have a coefficient of 1 on both of them. And you can think of this as we're going to multiply through by negative 1. Or you can think of it as subtraction. They're the same thing. I'm going to go ahead and rewrite, because why not? So negative 1 times y, negative y is going to be plus y, and then of course minus 4. And now we're going to add our two equations. The x's are going to drop out. I've got minus 2y plus y, so minus y equals 3. Y equals negative 3. And then we can go sub into either of the two equations to solve for x. This is the obvious choice here. because it's solved for x already. So x equals -3 plus 4, which is 1. So we've got the point x equals 1, y equals -3 as our intersection point for this particular linear system.